Everybody, welcome to Codeforces. Today I decided to participate in virtual contest. There's a very simple reason for it. Let me show you. So basically later today we have a contest from AAA and also some of his friends, I suppose. And I couldn't help but notice that he actually already hosted a contest on Codeforces. It makes perfect sense to participate in this previous contest. You actually get a feeling of how this person sets problems and things like that. There's no guarantees, of course, that it will help in any way or will get a similar problem, but it may help. So, exercise and walk. Alice has a cute cat. To keep her cat fit, Alice wants to design an exercise and walk for her cat. Oh, okay. Initially, Alice's cat is located in a cell XY on an infinite grid. According to Alice's theory, cat needs to move exactly A steps left, B steps right, C steps down, and D steps up. Okay. I actually forgot to copy my template, but it does not matter. I mean, virtual contests are mostly for practice, so we can write templates on the contest itself, I guess. And I know that this contest is like Div 2 contest, and we'll have Div 1 contest later today, but I still think it's reasonable to practice. Yeah, let me copy it just here. We have left, right, down, up. Definitely should learn some keyboard shortcuts, like I just copied, like moved it across like that. I believe there should be like some smart way to do it. Not exactly sure what it is, but there should be some way, right? So maybe like saving several minutes over the course of the entire contest may make the difference. Probably of like 10 or 20 rating points, but it's still important. Okay, so the moves can be performed in arbitrary order. Okay. Is always in the area x1, x2, y1, y2. Okay. Yeah, it's not realistic, let's face it. We'll just use std. Copy it here. Oh, we have several test cases. We don't want the cat to move far away, right? Okay, so the second line will contain all everything we need. So start x, start y, start y. There's left border, there's right border, there's like bottom border, top border. Is this the order in which they are given? Let's make sure it is. First start x, then start y, then x1 is the left border, y1 is the bottom border, I believe, right border and top border. Yeah, we can, I believe we can just break lines arbitrarily here, and it won't match it. Everything in line of sight. So, okay, I mean, she wants the cat not to leave that rectangle. Obviously, like, X and Y axes are independent, so it should stay just inside of each of these separately. We can check it. What else I can say? Like, I think it will only get out of the rectangle if it has like to move too far to the right, like overall. Yeah, because if there is at least like one unit of space, then he can just maneuver right and left. Okay, so we have several cases. If if bottom border equals top border, if bottom border equals top border, then if at least like down or up not equals to 0, then it's not possible. Because like he has no space to move, but he has to go like vertical. That's one if. If left border equals right border, similar thing holds, like if he has to go to the left or to the right, and it's not possible. If, however, there is space between borders, then everything that matters is like what is the general shift it has to make. So else we can put here just for convenience, and here we'll output possible, yes, no. We can put it once. Okay. I think it's valid, but let me just enclose in case. Okay, so here bottom border is different from top border, and what we are interested in is like shift x equals right minus left. So how many moves it has to move in the end, like overall. If plus x plus start, makes more sense to start x plus shift x. If it's smaller than left border, or yeah, let's call it final x. Or final x bigger than right border, then there's nothing I can help you with. The answer is false. And more or less the same thing happens here. But there's like more shorter way to express these if conditions, but I don't necessarily care about it. Line 14, I agree. Yes, no, no, yes, 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 okay. I mean, in these kinds of problems, it's important not to make any stupid errors. So That's why sometimes being verbose helps. Oh no, I guess I'm not a good teacher. uh, what happens? Damn, man, like what am I doing? Okay, sorry, it's early in the morning here, so I don't know what I'm doing. Like it should be, of course, like that. Yes, anyways, no. Let's check. Yeah, copy pasting code is bad because you often forget to should change something. So final y is like in this case when texture matters. Final y, final y. X is compared to right now. Okay. And that was embarrassing, but I guess it happens. It just happens. What? I don't understand. Start X, start Y, left border, bottom border, right border, top border. And there are no overflow because numbers are up 10 to the 8. What the? If bottom border equals top border, but we have to move, it's impossible. Otherwise, there's space for some manipulations, like you go here, 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 repeatedly. Oh, my brain is not working in the morning, apparently. So we have shift Y. Damn, man. Oh. Oh, it was terrible. What's wrong this time? Okay, that was terrible. Let's forget. And I don't know what's wrong with me. Positive integer is called composite if, yeah, I know. Sequence of n complete numbers. Once you choose an integer m less or equal to 11 or specific. One of m cars, so that for each car 1 to m there's at least one element of this car. Each element is caught and caught exactly one car. The GCD of any two elements that are caught. Same car is greater than 1. Oh, okay. So basically we can take like all even numbers in their own group, and then like all numbers divisible by 3 or something like that. Else show the writer that if all AI less than equal to 1,000, then she can always solve this task by choosing some m less or equal to 11. Less or equal to 11. What? Yeah, I mean, we can write input while we are thinking about problem. So she has like several numbers. That's not correct. She has several numbers from up to 1,000. Most 1,000 of them are because it does not make sense to have like repeated numbers. Okay, so we first print M and then we print colors. Okay, so basically like color corresponds to some GCD. And apparently one prime GCD, so it's like 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31. What is the next prime number? 37. Right, because 37 squared is bigger than 1,000, we only need these numbers. Well, okay, then I guess I will just copy it here. So I think from 1, okay. Wait. 7, 4. So we'll just color every number based on what its prime divisors. We'll have at least one here because like 11 is a number of prime numbers up to 1,000 squared. It should work. Okay. That's well. Huh? Okay. Okay. Right. Another map from it. Sorry, some of my friends were asking something important apparently. Sorry, right. And we can just do that. Like for prime and then color and colors. I guess we can add this construction. Uh, hmm. If AI is divisible by prime, we can say CI equals column. And then we can just always print 11, right? Yeah, yeah. Hmm. Right, because I did not print it. So we have 2, 3, 3 is, or actually we can break at the same time, but we don't care about it, right? We don't have to be like optimal over M. So this works. Like 6 is divisible by 2, 10, and by 3. And the index of 3 is 2. 11, yeah, color, like we can always output 11. I see. What? What happens? What? Each color should be used at least once. Man, that's uh, that's like awful. Like it's not the idea of the problem. Why bother with that implementation, man? That sucks, honestly. Oh, okay, okay. I just don't understand what's the purpose of that. It's like not the idea of the problem to make colors unique. It's just stupid. I don't know. What did you want to teach us with that? Nothing. Teach us like you. Literally nothing. What's I don't even know what like is a nice way to do it. Yeah, I don't have good feelings about the contest in Zeman any longer because it's not nice. Not nice. Well, how am I supposed to make them unique, like from one to N and do from one to M? Oh, I don't know what's like nice one. Just useless conversion. Like what is the purpose of all this? Literally useless. Okay. Let's do the vector. Find this one. Oh, it's okay. It's distance of lines. What's nice? No, I can't stop complaining. I just can't. It's like terrible. That conversion has absolutely no purpose. It's just annoying. I mean, I understand that it happens, but like what? So apparently, to use +1. Oh, and now we have to break actually. So, because we need to make sure that every number will be used. So now 6 and 10 are actually colored according to a multiplier of 2, and 15 is 3. Okay. Oh. Well, at least it's the wrong answer at 1, right? And not at 2. Both first test case is not penalizable. Excuse me? What is wrong with you? What? But it like compiles here. What's... Oh, do I really have to? I mean, to have no such version just sucks. Like, I thought it's a good contest and it's like nuts. I don't understand. Do I have to input something like strange form? Oh, really? Do I have to include an like algorithm? Maybe I need one more separate header for distance, huh? Really? Iterator, what the hell? I spent like 30 minutes figuring out the stupid details of these problems, not something like it is necessary. Yeah, let me answer my friends because it's something more or less important. Okay, I'm back. We are back with problem number 3. Finally, after half an hour, we have k complete word. The word of S of length n is called k complete. If S is a palindrome, okay, S has period of k, okay. For example, A, B is a 3 complete word, while A, B, okay, because it does not have a period that has, okay. Also given, Bob is given a word S of length n consisting of one lowercase letters and integer k, such that n is divisible by k. Wants to convert S to any k complete word. To do so, Bob can choose some I smaller than, okay. Replace the letter, have many replacements. Okay. So we have int k. S. Yes, isn't it like character by character, position independent, huh? We'll also need something like string. Wait, let's see. Example, no, that's small. For example, we have like A, B, A, B, A, but we want to convert period of 2, right? What does it mean to have period of 2? It's like every second should be the same, and also every second from the end should be the same. And the same with this one. This if these two are the same, we don't care. Okay. What I'm thinking is like for I from 0 to k over 2, we want to check that A S at I plus, I don't know, like plus S at I equals S at I plus k equals S at I plus 2k, etc. And we also want like S at, let me use notation of Python, S minus A and such. Something like that should be sufficient, and we just optimize several strings separately. How to get them to the same character? Well, we can select the most frequent one, right? Okay. So, print it. Let me think. Actually, if k equals 3, then I want to check 1. If k equals 4, I want to check 2. So I'm supposed to write, I believe, k plus 1 or yeah, we will use like an ordered map from character to frequency. For positions like this. Increments. F at SP. Also, if something is for positions this, we will also, if times I not equals k. Is it the condition? No, it's not. It should be like just like for 3, we only want to count 1 once, right? Okay, should be like that. Sure, this is necessary. I guess. I think something like this should work. It will require algo map. Okay. Takes a while. Oh, okay, because I starts at 0. We don't want to increment by I, we want to increment by k. Okay. That's why we were running in some infinite cycle rule. I think we should be good to go. Oh. Okay, at least one problem gets accepted from the first try. Actually, how much time do we have? Just for reference. Or I can, okay, we used 42 minutes for 3 easy problems. Bob is playing a game named Walk on Matrix. In the game, player is given an n by m matrix. Okay. Position 1, 1 with score A11. Okay. Right or down, as long as the player is still in the matrix. Player score to the bitwise end of the current score and the value of Bob can't wait to find out the maximum score he can get using the tool-heuristic alarm dynamic programming. But it's like bitwise and you can run into some issues very quickly. Huh? Huh? Okay, oh, okay, see what? So here, this algorithm is clearly suboptimal and want to find the difference when the difference is exactly k. What the heck? I mean, like one example that I had in mind was the following. Like we have, for example, 3 here, 2 here, 1, 1, right? And it's like the first optimal way is to go here, right? No? Man, that's like, what age is this? Like when you have an algorithm that you want to check if it's correct. Huh? It's like a typical interview question. There's no place for such problems on contests, I believe. Also, there are some bugs. Maybe it's like a reference point. I'm here not to read people's code. I'm here to write my own code. What is this? So he basically considers two paths, right? So he does not go greedily, but he goes. I don't understand. Each DP point has a reference as one of the two previous. So with 2 by 2, we won't get any contradictions because all paths are covered, right? If there are only two paths like this and like this, and each of them is covered, like if we remove one of these arrows and leave. So DP is like it has one arrow going back. It should fail for some reason. I mean, I'm pretty confident that it failed because it's prefix and strange function. So here we have like, let's see, for this vertex, like the arrow will always be this one, right? So, and same goes for these two, I believe. We actually draw them in green to distinguish this case. Like DP will always say that the best parent is this parent because there are no other parents. Then we can have different situations. We can say that this is optimal and this is optimal, right? But then maybe optimal paths involve like flipping both edges. Is something like that possible? When we say like again, okay, like disregard this. Oh, okay. Let's say 7, just like we have 3 set bits, right? I don't care, we can keep 7 here, here, and here. I think here we can't actually keep it, but here and here it does not matter because we have only one part. So, okay, I see. So this should be better like this way if we get it this way. And it should still be better like if we go this way. I don't understand. This is still the better parent for this, let's say, because we have like can we actually have something like 4 here? No, then it will find like optimal answer. Wait, that's strange. Like here, the answer is optimal. Like what? Oh, okay. So it should be max, but it should lack some bits that are important. It should be max. It should lack some bits because let's say we can't set these bits here. Let's say. So the number in the actual matrix can be like 6. And it was a construction problem and like read other code problem. What the hell is this conflict? Honestly, I don't want to participate tomorrow, like today, later today anymore because it's like, oof, okay. I mean, I have to. Otherwise, one get like positive rating challenge. You can't get positive rating challenge if you don't participate in contests. So does not make sense not to participate in contests. Then we should like keep lower bits here. Say 2. I don't know, we can put anything here like 0. Actually, here you can put like 7 and here you can put like 3. Right, and what will be the DP state? 7, 4, 0, 3 is the best prefix, and here it says 4 and here it says 0. But the actual answer involves like going this way. Okay. So the difference is 3. We don't want, okay, so we don't want the difference to be 3. We instead want to do is we want difference to be k. We can put k here and here. Then answer will be k. And instead of k is up to 10 to the 5th. So here we can safely have something like 2 to the power of 20. Okay. So the actual matrix that we want to print is like this. Here goes 0. Here is k, here is k. Here is 21 minus 1. Then optimal path is like this because it has an end of k. But who is the optimal parent? Like for this is optimal parent, this is optimal parent, this is optimal parent. It's no brainer because we don't have another parent. But here, this is better. So DP won't consider all paths going like this. Then it says like, well, I actually don't care because by this time, like both this and this is 0. So yeah. We want to read. What do we want to print actually? Oh, we don't have test cases here. Why? Also, we have annoying test cases like k equals 0. N and M. N is number of rows, number of columns. It's just I guess I'll rather. Yeah, it's really annoying to test when you have like 0 test cases. I guess like the answer is 0 anyways. So. It will be just like whatever I type in, right? Okay, so the problem is like DP always chooses optimal parents and then disregards paths that go through suboptimal parents, even though they can be better in the long run because like bitwise end is just a strange function. What? No, wait, I just tested it. It's correct. Like difference is. What? Hey, that's unfair. Do I have? Oh man, that's a 9. What's the purpose for this? I mean, it does not matter. What the? Oh, I just don't understand this person. He just makes everything annoying for no reason. I can just type 18 here, 18 here, and 17 here. This is a stupid way of giving problem because constant of 3 is not like general. General, you need 4 to have 2 powers of. What did you want to teach us? Why being precise? Do you really care? Does it's not matter like in which input the algorithm does not work. Like we prove that it's wrong anyways. What's this point? Yeah, now it's obviously passes. What the hell is that? Well, at least we figured out that he's like sets these annoying problems when constraints are necessarily tight. Like you figured out the correct idea. Why do you want like exact constants? What is the additional educational value of shrinking constants, like having numbers that's like 8 times smaller? There is no educational value. Alice got addicted to a game called Sorted. Oh, it's like three-dimensional Tetris. Something. And by M root Aij cube stacked up in the cell Ij. Adjacent to the shared site, okay? Stack one cube in two adjacent cells, stack two cubes in one cell. Okay. Sorry, it's really too early in the morning. All heights of all cells the same. Yes, like if initial. Oh wait, you can stack two cubes. Yeah, your basic problem is like when parity does not match. What's number of initial grids such that every element is between L and R? Can reach the goal. Well, it obviously has nothing to do with fast Fourier transform, although we may need some binomial coefficients. Thank you for necessary form. Oh, I guess it's because like separators are different in different languages. In Python, we have like underscore and here, like, oh, okay. Again, no test cases. What's the purpose of having no test case? Like in the previous question, output was reasonably small. Like you could just ask n to be like up to 100, then you can stack like uh, at least, yeah, at least 20 test cases into one and have like 5 test cases instead of 100. Huh? How about that? Like there's the reason why we have like several test cases stacked into one is because multiple test cases make the queue slower. So you have to invoke executable file after it was compiled and each sample separately. There is some unnecessary overhead. Like it's okay if I'm like the only person who's submitting, but otherwise it's just strange. Yeah, let me actually take a break because I'm a bit annoyed with the problems, and I will come back soon when I'm able to like, actually think about problems. Oh, damn. I forgot that I turned off the microphone. Well, I guess it will have to be this way because we can't code, right? Actually, I was thinking like the first thing that you can notice is that you can make everything 0 and 1, and like the sum of all numbers have to be even because you always add 2, or actually not even, but of the same parity as n times m, which is interesting. If both of them, okay. Actually, if both of them are odd, isn't it mean that we can always equalize? Yeah, I also was thinking like when we switch a pair, right? Like flip pair, right? So if we like consider such paths, then we'll flip only the endpoints. So we can flip any pair of points, and it only matters like the parity only matters. We'll need this like for k to the power of that. Yes. Okay. If n times m is odd, if m times n is odd, so if both of them are odd, then we can just, any grid will work, right? Because we can go like to change this pair, change this pair, change this pair. What if we have like an extra 0 somewhere here? So we change this pair, this pair, this pair. Then we can change everything else in pairs. Yeah, we don't necessarily want to turn everything on. We can turn everything off. Right. So if n times, yeah, now it actually makes more sense to make this if statements like this, right? So we have like a test case when they are both even, that's product even. And the answer is just yes, and we can output mod poll of k, I believe, number of options. N times m. I think it's n times m. We can also write it here. And then just keywords, right? I mean, it's default parameter, so we can just leave it as this. Else, n times m is even, and k is odd. I think that it's impossible. No, not k, okay. It's impossible when number of set things is, by the way, mod. Oh, you can't actually mod multiply. Power can be in 64T. Here you have, okay. Right, on the parity, it depends on the parity of k, how many options we have for this one. For the previous ones, we have that many, I believe. Yes, this is number of ways to choose. all of these if k. Wait, isn't it like always? Okay, if k is even, and for the last place we have exactly half of them. So we are supposed to output like a module k over 2 and then r. Right? Correct? Is this correct? Also, test cases like shit. Let's face it. No big test cases to check user correctness, so you're just like on your own. That's really not nice of you, I mean. Yeah, I think I should stop complaining and start solving problems, actually. Continue solving problems. But here, it's like the last, if we have like 5 ways to fill the last place, 3 of them are good, 2 of them are bad. Like here, for every test case, for every like a first n times m minus 1 numbers, you have k over 2 good continuations. But in the case above, you have like, it depends. It depends. Do you have k minus 1 or k over 2 or k over 2 plus? Well, let's see actually, like what if we have 9 of them and we have k equals to 5, right? No, if n, okay, we have 12 of them and k equals to 5. Then, there are k to the power of nm minus 1 ways to fill this in. But I'm actually interested, like, how many of these ways are continuous in how many ways, right? Wait, want it to be like, okay, let's say that A is number of ways to fill it in that ends with, that are good, B is number of that are bad, and we have like S is size, right? A S plus 1 is like, good is which ones? The ones that have odd number, even number. What goes on? It's complicated. There should be like K AS plus k minus, and this are not k, it's like k over 2 actually. Here's bs, something like that. And the other is just complement. Ooh. There were like 5 ways to fill it in, 3 good. No, all of them are good. Okay, all of them are good. Then we continue. Then we're interested in a 4 plus 9 versus 2 times 2 times 3, which is 12 and 13. Right? And all of them are good again. But how many of them are 0 and how many of them are 1? The good ones will be 12 times 2, 13 times 3. And the bad ways will be 13 times 3, 13 times 2, plus 12 times 3. Wait a sec. This differ by 3, this differ by 2. Oh, they always differ by 1. Okay, okay. So they always differ by 1. They always differ by 1. Which means we should do this, and we should add 1, and then we should divide by 2. Okay. Sure. Say I want 1, 3, 0, 4. This is correct. 1, 2, 0, 4. This is correct. Okay. We don't have much time left. Oh, I wanted to go to submit directly. Sorry, I got distracted by my which means syncage speed. So far, so good. Okay. Man, it's like not very interesting whenever problem is math problem. What are the standards? Okay, so a lot of people already solve it, and we want to solve F if we want to go like anywhere. Very good. Just stop spamming. Okay. Right. Hmm. Independent sets. Well, okay. I don't know much about independent sets, but I do know something. I can't exactly say it's like independent sets, but I guess we'll have to deal with them anyways. So. Eric is a teacher of graph class, theory class. Okay. Independent sets and edge induced subgraph. Okay. Given in graph, yeah, okay, I know the definitions. Okay. Yeah, no, I mean, like you select some actual edge induced is stretch word, because it's actually induced by vertices. Or no. Okay, I see. So you select all edges and then vertices are the one. Okay, so it's correct. Edge induced. Okay. Oh, I'm not thinking now. I'm just terrible. I don't know how people write contests in US. It's early in the morning. I guess you have to have a really good sleep schedule. Okay, given a tree, calculate the sum W of each of all except no edge into subgraphs for WH number of independent sets in H. What the? Why is this a diff2 problem? Like, what person in diff2 will officially solve it? No, that's just ridiculous, isn't it? Yeah, that's so like very little people, like 7 people saw this. Lol Python. Okay, as you wish. Actually, Python is not that bad, right? People, but no, like only in Python it's a bit tricky. So this is a strange time, like 10 minutes, 20 minutes, and then like this order. What? But yeah, some people do solve. We are somewhere like terribly far back. Why is this actually? I thought the diff to rounds are like visual Codeforces rules, no? It's only for combined rounds. Also, we're actually not bad. Yeah, but once she'll solve this problem, she'll be up. We are obviously done on time. And also plus 2 is like, huh? Other grandmaster must be solving something like here. Somebody clearly showed up to a contest late. Like 1 hour late, maybe. It's funny. Yeah, okay. Well, actually, I have to think about it. And I also need to take a short break, so I will come back as soon as I can. See? Okay, I'm back again. And I have no idea what to do with that problem. Okay. We have a tree, and here we have some like really terrible constraints on what we want to count. So actually, as I was AFK, I thought about like having a projections, sort of like what if we exclude an edge and then like we get the tree disconnected, we can change the coloring of one component, therefore it will like correspond to multiplying by 2, but then I realized that there are like different scenarios and there's no clear projection. So that's pretty much everything you missed in the last 10 minutes of me thinking while AFK. We haven't actually read the input, so let's do this now. We have n-1 edges because it's 3. And we have no idea what to do. Like, removing edges is actually a huge problem. Because there's clearly no way to like iterate through them or enumerate them in a nice fashion. It would be much better if we like counted. It would be much better if we could compute the number of colorings that are good for some right. So it's like basically double counting. Okay, this idea is clear, but it's not done yet. So the way it is currently written is bad. Let me show you why. They say like it's the sum or edge-induced graphs, so our subsets of weight of GE. right? And the reason why it's bad because we have no idea how to count edge colorings. What we can do instead is we can define a different function. So we will count our colorings, let's denote colorant C, and denote like age of C is how many how many uh, edge induced subgraphs have this coloring as an independent set. Yeah, coloring and independent set is like interchanging because I'm interchanging them because they used coloring here to denote independent sets. This coloring is you have to remove this, right? You have to remove this edge. Also, it's a tree. It's just some dynamic programming on a tree. Yeah, I think this is basically it. So we have double counting idea in edge and DP on a tree. Oh man, okay. DFS of G and 0. I don't care what vertex it is. Int? Is it int or is it not? It's unclear what it should be. Yeah, I think we'll need this function. Okay. That's probably this function as well. You see, we want to count. At least we'll need the distinction between like having a color and not having a color. So we'll need to return like whether how many ways to color subtree with this vertex colored and this vertex not colored. So it will be like colored, not colored. And then we actually want to like I think right, actually I do have C++ 17 here. Have structure. And it doesn't matter how you root the tree, it only matters to actually root the tree. Okay. Because 0 will right. So we have here we have vertex and parent. Thinking 1 should be a good start. For consecutive vertices in G3, if it's not parent, we're actually interested in doing sums. What is it like? Okay, so the answer will be the product like in different subtrees. Okay. So how many ways if we do color this vertex, right? If we do color that vertex, then like if so yeah, okay, for some edges it's 2 if we can remove and can keep it, and it's 1 if we can't do anything. Okay. So the answer is DFS from GUV. Answer first. Let me think actually. If no, not like that. Oh, that's complicated. Okay. I think it's sub-bands per second. Yeah, so the idea is the following, like, let me draw action. We have a vertex. We know if this is colored and this is colored. Okay, if both are colored, then we have to remove the edge between them, because otherwise they won't be independent. So there's only one way. So that's why the coefficient is 1. If this is, however, not colored, then we can just, we can both retain, edge can stay, edge can go. That's why we have multiplier of 2. And then we'll, with seconds, if we don't take, I actually think that we are good to go with this. If you don't want to color this vertex, then no matter whether this is colored or not, we can just edge can stay, edge can go. We can remove, we can leave it. Is it really that simple? We're suspicious about that. Okay, let's add, let's we can say like so. As usual trick, we first split not minus. Is it F already or that's a diff 2, okay. Where exactly? 23 vector, okay, makes sense. 7 is not the correct answer, but just how bad it is. Okay, so we definitely our count, right? We do our count, okay, but when? What is a graph actually? In this case, graph is just like this. For some reason, we return 7. What? Why? Like, okay, in this case, we have one way to color, one way not to color. And this vertex says, like, if I want to get colored, and you're colored, then I have one way. If you're not colored, then I have 2 ways. So I have 3 ways not to get colored. If it is, however, not colored, then it does not count. That's why. No, but wait, like if this vertex is not colored and this vertex is not colored, and we can't remove the edge because it will break connectivity. We don't, and it's not be edge induced. So we want to. So this should be connected to something. Well, it's getting complicated. Subtrees should be okay. I think we'll need more states, I guess. If 2 states do not work, then we just can more states, right? Like we clearly need to know whether subtree is connected to something or not. And some are not connected when you remove all edges. Okay, okay. Yeah, okay. We want not this, but not. I don't know how many exactly states there will be, so I'll just make a vector. That's not great naming, but sometimes you got to do what you got to do. You can literally do this, don't even return. Interesting, right? In this case, it's easier to go this way. In this case, it's easier to go another way. So we have a vector. It starts with color, not color, but then we want like it's disconnected. We're actually only interested in disconnected. How many ways to have disconnected? One, right? Wait, do we want color one leaf, then we have 1, 1, 1, but the answer is like not like that. Like, okay. Is it like that? Connected. Right, we were running at the very beginning, like an empty graph, like with one vertex would return 2, and at least now it returns like 1. Yeah, we definitely need to have our own number theory class. The downside of participating in many contests is that you have to not always have time to like develop your library and things like that, which is really not good. I believe here it will be clearer if we actually keep coefficients like this. So we should subtract the ones ones. This is paired, so we want to subtract here. So the ones that are disconnected, we can't leave them on colors. That's what we're gonna do here. Yeah, that's some real shit in code. I'm terribly sorry about that. But sometimes you gotta do what you gotta do. Yes. Maybe it'll work. And we also need to transfer seconds. How many ways to get disconnect? When you don't draw an edge. Wait, isn't it so basically subtract the answer 2, not add answer 0. So answer 1. And from here you subtract this. You subtract this. Answer 38 is incorrect. Why? vector. 4 is not a correct answer. Maybe it's just -1. I don't know, people. Maybe we count like an empty subset when there's like one. There is just one of them. Wow, 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 wow. Can we wait? Is this true? No way. Do we really solve F? div2? I mean, like, I solved G in div3, but F in div2 is like, or actually, I already solved D in, oh, okay, cool. And I already solved D in div1, which should be like F in div2, but it sounds like quite hard. Yeah, this is terrible code, but all it does is like modular operations. Definitely need to take a short break from making all these videos on contests to make actual videos on genes and improve my library, because that modular code is not the way you want to write the code. Unfortunately. Oh, that's huge. I only have one problem left, which does not look particularly solvable, you know? Okay, even F already like 120 people. I understand that it's like div2, but still. Yeah, like only like a while. Finish the contest. What language is that? Rust? Impressive. Python, even more. Well, actually, like this one is I'm impressed. DFS and Python. That's good. Oh, we actually like not bad. Yes, definitely like having 7 problems in 2 hours, 30 minutes helps. Look at we look at for instance. I don't think we can solve G. I mean, I'm really tired and I don't particularly like problems, so I don't think I will solve G. Okay, so the grandmasters basically know what they're doing. Okay. And also much faster than me, like the differences to times. Well, here sort of equalized because actually like here I took a break. Here I took a break. So it's not very accurate, but also here, I could have been rather better if we didn't take breaks. It's interesting. It's really interesting. But some well, maybe, you know, for them it's unofficial, so you can relax, show it. It's math problems, so not everybody likes to solve math, apparently. By the way, that's a really cool guy. Earlier today he sent me, well, he didn't send like me directly, but he sent to the Discord server that I'm in some music, and it's amazing. I'm still listening to that band. I really appreciate it, man. It's really cool. Yeah, I think it will be it for today. I don't know, think that we actually have to explain like problems again, because like I tried my best to explain during the contest already. So I think it will be it for today. If you want to, yeah, again, just a reminder of why we are solving this in the first place. It's because it's only because we have triple A as problem set. It actually lagged for a bit, so okay. No. That's the way. So yeah, we have triple A. Here's a problem set for today's contest. In particular for div1, I believe like this guy set problems for div2 mostly, and he was like for div1, but maybe I'm wrong. And it's the other way around actually. And he was the problem setter of that contest. So I wanted to get a feeling of how like his problems are, what he likes to. Wait, is it like this? Oh, okay, so it removed the first, yeah, okay. Okay, so yeah, several thoughts on this problem set. Huh? Oh no, I agree. What editor? Sublime is not running at the moment. Uh, hmm. It's not. Okay. So several thoughts on the problem set. This person likes some, in my opinion, unnecessarily tight constraints. So this is definitely a thing to watch for today. Like you want to make sure that your code does exactly everything that's written in the statement, because like all constraints are important. He's also more or less a math person. topic set is more or less the same. It's usual. There is some 3DP, there is some construction problems, there is some math problem. There is some even strength problem, which is not often, but it's more like implementation. I feel like ABC were only for Div2. So yeah, it's probably the reason why this was not published like as Div1 contest also, because they had only 4 problems suitable for Div1, because this is just too easy implementation. I don't like this kind of sync when you have to read some algorithm, but it's not particularly difficult. It's some bitwise operation, but only like basic ones. So I hope for no like complicated bit manipulation problems. Overall, I liked the math involved. And I definitely need to do something about our number theory. Does? Wait a second. I think I know who can help me with my number theory. Go to James. Well, that's not, I mean, well, we can solve it someday just for like, but I don't think it's representative in terms of Codeforces. It should be more about like representable in terms of code chef. Wait. Well, I don't know. Like if you know good problem sets on numbers here, definitely let me know. I think Anand has one, so I definitely should solve this one. But otherwise, other than that, I don't think that I know any like particular good problem sets. So yeah, I hope that this short overview of the past contest was helpful, because you got some ideas, you know what to expect, and I guess we'll end it with a quote from Sun Tzu. If you know yourself and you know your enemy, you need not fear the result of 100 battles. So yeah, getting to know your enemy definitely helps. I think like now I'm much better prepared in terms of like watching for tiny details. I will remember that. And I mean, Codeforces is often about not how good you are overall, but how good you in a particular round. Right? Rating changes are significant. So yeah, you have to perform really in the round to get a good result. And to perform in the round good, you have to know something about it. You either get lucky, because you are overall good, or you can just solve everything because you're overall too good, or you have to be prepared. So yeah, that's all I wanted to say for today. Bye bye. See you in the evening.